Hello and welcome back to another session of the Raytracer challenge, where I implement in Rust a Raytracer together with you based on this book, the Raytracer challenge by James Buck. Until now we have created a quite nice and little Raytracer here, which we even compiled to WebAssembly to make it available in the browser. You can use this by just visiting raytracer.xyz. And you can play around with it and follow along what we are doing here. You will find all the sources and the source code of this, as well as all the resources, are down in the description below of this video, where you can follow along. What did we do last time? Last time we implemented patterns and we implemented the possibility to specify transformations in degrees and not only radians. Let me quickly show you what we did. So we cannot only specify a color here now, but we can specify, let's maybe quickly do this, a pattern here by specifying a type then, which would be a striped pattern, because we've only implemented a striped pattern yet. And I guess, as I remember correctly, a stripe pattern needs the color A, which is, of course, the first one. Let's do this as a black, and let's give it a color B, which is a second color. And as you can now see, this one is patterned into two parts, the black one and the white one. But we might want to transform this a little, so let's add a transformation here of type scale, and the parameter 2, let's scale this by, let's say, 0.2, 0.2, 0.2, so that we get more stripes. Okay, this does not work because I should have made a comma there. So now we have a little bit more stripes there, and now we can actually, if we want to, type rotation. Let's rotate this around Z. Is it rotation Z or rotate Z? We will find out. I'm not 100% sure. And what we've now implemented the last time is that we can now specify degrees here. For example, we can say degrees 45. And what you cannot see are the arrows displayed down here. So it now says to me that rotation Z was found, but he doesn't know the rotation type, so the transformation type, so I guess it was rotate Z. Try to get value with key radians, key not found. Okay, did I not roll out the change we made with the degrees? Let's see. Actually, let's reload this whole thing without the cache, and let's see what happens then. Okay, now we have the newest version. Okay, so some kind of cache invalidation error there. Okay, and now it seems to run and work. So maybe I will need to take a look at if there's some cache header not set correctly, so that the system doesn't get correctly informed, or the browser doesn't correctly get informed that there is a new version available. So, but now we have the newest version, as you can see, and this is what I wanted to show in the first place, that we can now have this, where is it? That we can have patterns, like the striped one here, and that we can apply rotation transformations with degrees instead of radians, which is a lot more comfortable. So yeah, let's go on and let's see what we are going to do next. The next thing I wanted to do was to clean up things a little bit, because we have missed some tests and weren't 100% structured about what we did there, because we just implemented stuff without adding the proper tests. And I wanted to add those tests now, just to be in sync again, kind of with the implementation here. I thought about doing this off camera, but then again, I thought, yeah, maybe some of you find this interesting, so let's do it on camera. And if you don't want to follow me writing those tests, it's fine as well. Just skip over it and watch the next video or something like this. But for those of you who are interested in this, this might be kind of a nice thing to have, and I would have needed to do it anyways, so I could film it. It's no difference to me. Okay, so let's see. What we did last time was we implemented a lot of stuff in the WorldLoader, and I wanted to have tests for this as well. Not this WorldLoader, but the YAML WorldLoader specifically, which now has those degree tests. We added those, but I'm quite sure I have some to-dos or fix-me's in here. Yeah, there. To do add tests validating the pattern parsing syntax within a material. So we did not at all check that our, where is it? Pattern parsing syntax like this one here, which is a block of YAML which is parsed here and then transformed into a pattern struct in the context of the Rust Raytracer, is tested. And I guess we should do this just to make sure that everything works out as expected. So let's see, what kind of tests do we have here? We have something that loads up a simple world, and it defines a light and some body with color and so on. We more or less should be able to copy this test to ensure that what we have there in the end is what we expect. So let's copy this one. Let's just put it somewhere down here. And then let's get going. So yeah, the system obviously tells us that we have a test which is already named like this, and we now call this one pattern syntax in bodies is parsed, or let's call it, as we only have one which we can parse yet, let's call it striped pattern in body is parsed. Yeah. So there's the underscore which needs to go away. Okay. And now what do we don't need here? We don't need a camera here. We don't need a light for this test, but we need a body. And this material here is okay. We have a Phong material. We don't need this specificities of the specific definition of a Phong material. We'll just use the defaults. We don't need the transforms here, but we need a pattern here. So yeah, why not take the one we just defined here? Because yeah, why not? Maybe we will change it a little bit, but let's see. Okay, so now we have a pattern here, which is a stripe pattern, and now we could define our expected world. We would want a new sphere there, which is defined a new Phong material, but I guess we just want the default Phong material there. Do we have a default Phong implementation? No, I guess we don't. I guess we wanted to refactor that. Let's see. Do we? Don't we? Okay, maybe let's start a little bit different and not have this. Let's see. Let's call this one, because I'm not 100% sure anymore, because it's quite some time. It has been quite some time ago how this material is defined. So let's start here by saying we want a new material. And we want, of course, a new Phong material. And Phong does have a default. So, okay. So then we want a material, which is just our, the material is actually just our static dispatch container. It's an enumeration which can hold all different kinds of materials, and it's then statically, where is it? Where is the material implementation? Come on. So the material is just implementing then somewhere, should be, there it is. It's implementing illuminated, which is our kind of material trait, and then it's dispatching to the correct materials based on what kind of, or correct implementations based on what kind of specific implementation this is. And this is kind of a static dispatching, which can be decided during compile time with or in contrast to an implementation which we could have written that decides this during a runtime, but it's not needed during runtime, as we have full control over all materials that might be there because they are all inside this library. We can actually decide this during compile time, so why not do it? And it makes things a little bit easy for us. So yeah, now we have our material. So let's see. We would, I guess, have our body, transform there, which would be a matrix identity, I guess. And yeah, then let's see. We would have a sphere here, which would be a sphere. Actually, do we have a? We can have a default sphere. Do we have a? Do we have builder functions for that? I'm not 100% sure. That's definitely something I wanted to refactor, but as it seems I did. So this is quite nice. So we can just get a default here, and we can say we want the default one with a material, which is our material, which we most likely wouldn't even need, as I guess the default material of the default sphere would be a default Phong material. But yeah, this way we have specified it out. It's nice as well. So, and we want it with a transform, and we call this one body transform. So by the way, sorry if I'm pressing the wrong keys today. I have a little bit of a a lame hand here, which is not perfectly for writing at the moment. So please bear with me while I might do some errors like those. So okay, now we have this one, and let's encapsulate this one. Let body equal body from sphere. Essentially, this one is the same thing as with the material. It's just a static enum dispatching. And now let's for now remove all of this stuff here, I guess, and maybe we don't even need this world here, because maybe we can just have a list of defined bodies, I guess. So let we of course need to integrate into this material later on. We need to integrate our pattern, which we might as well do just now. So let's define this one here, and let's say let pattern equals pattern from, and it's the same thing. It's a static dispatch again. So we have our default striped pattern, and we have it with colors, I get, not with transform, but with colors. There we go. Color A, which is a color. So color new, and we defined it as 0, 0, 0, but those need to be floating point values here. So let's do this one there. And we of course need, maybe we have splitted it out like this. So let's maybe just really split this out here, just for better readability, because I guess I want to maybe change parts of this test later on as a second test, and then this will make things a lot easier. I could even then use a macro for this, but I guess I won't. So The second color here was all black. No, actually, I'm wrong. The first one is black. This one is white. Okay, so I guess we even have those. Let me quickly check. I think we have. Yeah, I could have even used this shortcut creation function there, but okay. So now we have this with color here. So let's just quickly fix this one up. So we have color A here and color B here we will put in there, and we would have like a pattern transform, which would be a matrix. Let's see, we have the scaling and the rotation here, so we would need rotate. No, this one is rotate. Yeah, the matrix function to create it is called rotation, and we called it rotate in the YAML. That's why I'm always confusing the two. Maybe we should make them identical. Not 100% sure, so not X but Z. And we wanted to transform this in radian. Do I have, where did I implement this conversion function actually? Because it would be nice to have this in the matrix. Let me quickly see. I guess I did it in the YAML parser, degrees, and visit radians or degrees, yes. So let's go there and let's see, and let's so actually I'm not using a conversion function here, but just doing it on the fly. Maybe we should add a conversion function for this in the matrix. Maybe not. Yeah. Okay, not that important. Let's get back to our test. Don't let me get sidetracked there. So the rotation we would like to check here was degrees 45, so it would be actually 45 divided by 180 times pi. So let's see. This should actually then be the right value. Did I have is there a missing? No, there's just a missing semicolon there. So okay, let's format this, and now let's do oh, we missed the scale, so we want to multiply this with what is it, scale? Is it scale or is it scaling? It's scaling, of course it is scaling. So we had 0.2 there, 0.2 and 0.2. So this should actually be our pattern transform matrix. So let's add this here with transform, pattern transform. Okay. Okay, so now we have actually all of this stuff together here, and let's remove this one. Yeah, let's instantiate our default loader here, which would then give us the world. Yes, and it would give us the cameras, which we would assume are empty. So let's just not even take a look at them. And let's just do the following here. Let's assert equality, that we are expecting a loaded world to have bodies dot len should be 1. So we would expect that we exactly have one body defined. And then let's just assume that our body is fuzzy equal to loaded world dot bodies, and let's get this body there. So yeah, maybe we should try and see if this test runs. Cargo run test. No, cargo test, not run test. Yeah, okay, so why is this actually failing? Something did not match up. What did not match up here? Yeah, okay, so nothing wrong there. Color A and color B seem to be okay as well. So where exactly is the difference? I would love, actually, for those outputs here, if such an assertion fails, to have some sort of highlighting where exactly this fails. If anybody of you knows some sort of Rust thingy that can help me with this, I would be very glad to have you tell me, because I would very much like that to better see differences here, because obviously there is some sort of difference here, but I can't see quickly where. So I guess I will really go ahead and diff those things. Let's not do this in Visual Studio Code. Yeah, I know, but the VI thingy here, let's do it. The VI emulation just only goes so far, so let's put this in VI and let's now do a search and replace here with the regex, which tells the system that we want. If we have something like, let's see, a curly brace, an open or an open curly brace or no. So an open curly brace or a closed curly brace, or let's see, an open square bracket or a closed square bracket or a comma, then we would love to replace this with the thing itself plus a new line. Okay, I guess I have to escape those then, maybe? No, I guess I do not need to escape the curly braces, but I need to escape the OR commands there, maybe? I guess so. Yes. So, now at least this is a little bit better split up, and we need to somehow find the place where it is. Exactly, this one here is not fuzzy equal to, so we delete this, put this in the next line, take this out of there. Write this, and let's put the other one in another file here, and now let's do a unified diff between foo and bar, and let's see what the heck is different there. So yeah, this is, we don't care about this, but this one, no, this one is actually okay. Those two values are identical. There is no difference. What the hell? So we have semicolons in there, yeah, but I guess this is only a formatting thing. The values are the same, actually, so maybe our fuzzy equality check is running amok there, or what is actually the problem with this thing? Let's run this again. Okay, at least it is failing consistently. So let's do something different. Let's check if they are equal. Not fuzzy equal, but equal, because maybe we simply have a problem in our fuzzy equality check. Okay. This is something I actually didn't expect and something I actually don't like, because we have somewhere made something. We broke something somewhere in our fuzzy equality check. So let's can we somehow see what is broken there? We could actually maybe see something like fuzzy equality for body. Should just call the fuzzy equality implementation on, no, I didn't want this one. I wanted the sphere fuzzy equality implementation there. So fuzzy EQ for, no, yeah, it should be fuzzy equality sphere some. Yeah, it would be in the sphere RS, I guess. So let's see, fuzzy equality. There we are checking fuzzy equality on the sphere, which is in turn checking on the transform and on the material. Maybe this would be time to get to know the debugger. I actually never tried to run code with a debugger here, but I would love to have a breakpoint here now to see if this actually would, or which one of those two here returns what, so that we see which branch we need to check further. So first of all, okay, let me see. Let's try and find quickly check this out. If I didn't mention this in the beginning, and you might not know it because you are seeing this video out of context of the other ones, I've never done Rust before starting to write this Raytracer here. So I'm learning Rust while doing this Raytracer, and I've actually never used the debugger with Rust. So yeah, maybe this is a good time to find out how to debug Rust. Okay, so let's see. First of all, I would need to see that I only execute the, I guess I changed it back again, so only the failing test. That shouldn't be a real problem, as I guess we can just provide it with this identifier and it should only execute this one. Yes, perfect. So now I guess, and we can, as far as I know, can do this within the IDE. Yes. Okay. So this is running one test. Okay. This seems to be quite nice, and there is already an automatic debug thingy here. What happens if I just start this one? Okay, so I guess I'm now getting the disassembly, of course, but yeah, it's calling it with GDB, I guess, or what? I'm not 100% sure. But that's actually not what I really wanted there, but maybe if I'm now putting a breakpoint there, and let's see. And now I'm running this in debug mode. What happens there? Oh, nice. Okay, so let's see what's the, yeah, actually I would have to needed a debug point there, wouldn't I? So let's see. Now we should have the result value from this one, and can we actually, do I need to registers global? Maybe I need to, I like that this is, it's integrated like this, so I can actually inspect those structs here quite nicely, and it is resolved for me, and yeah, I really like that. But how would I get those values now? There may be another way, but let's see. Let's just put them in local variables and hope they are not optimized away during compiling here. So let's just have the transform equality equals this one, and have let material equality equal this one, and let's return transform equality. logical and material equality both need to be true for this one to work out. And now, if I'm actually just removing this and putting a breakpoint there and running this one test again in debug mode, so let's see. I should actually be able to, okay, the transform equality is true, the material equality is false. So we need, we know that we need to go into, no. We know that we need to go into the material and check that the material fuzzy equality, what's actually happening there. So the material equality is here checking that the Phong material, yeah, okay, so it's matching based on Phong, and if both of those materials are Phong, then it's doing a fuzzy equality on the Phong material. So let's check out where the Phong material is. There. And Phong material should implement fuzzy equality. And this one does some sort of fuzzy equality on the color, ambient, diffuse, specular, shininess, and pattern. And let's just, I'm guessing, because the only thing different from things before is this one, the pattern. So let's see if, let's quickly follow my a hunch of mine and say pattern equality equals this one here. And let's put this in there, and let's, there is a T missing, and let's see. I would assume if I put a breakpoint there and I run this test that the pattern equality is false. Yes. So, okay. So the pattern equality is, we can remove all those changes later on, but for now let's keep them there. So let's see what the pattern equality here is. So we have a fuzzy equality of a pattern there, and it's fuzzy equality on a striped. Is maybe this the problem, or is there is fuzzy equality for pattern? It's the same thing, I guess. It should be directing us, yeah, to fuzzy equality of striped. So striped and other, this is right. So this will be called then there. From striped, no. So we are getting here, and we are, yeah. And there is the error already. So self color A, fuzzy equality other color B. So this will of course always be false. So let's fix this here. And now let's do a cargo test again. And now our unit tests are running through. So yeah, it's a good thing that we wrote this test, and I like just having to take a look at the debugging capabilities here, which seem to be simply active and enabled in Visual Studio Code if you are using the Rust analyzer and the corresponding extensions. This seems to give us a debug environment already configured for our project in Visual Studio Code, which is quite nice. Otherwise, of course, I'm sure you can do this with GDB, as you could with any thing there. I guess debug symbols will be created and generated in a debug build. But yeah, so let's quickly at least commit this change here we did. So let's do a source pattern, I guess. Yes, and this is the change we want there, and let's fix fuzzy EQ for striped pattern. We were comparing color A with color B, which of course resulted in a broken fuzzy equality comparison. Now the comparison is done between color A and other color A, as it should. Okay, let's push this, because why not? We can directly do this. Yeah. Okay, so let's get back to where we were when all this started. We wanted this test, and as it seems, the test is already working out. So maybe, just maybe, let's copy this one here and do another one of it, which will be striped pattern in body. Let's call this colorful striped pattern, because I want to make sure in body is parsed, because I want to make sure that that some sort of other color than the default is parsed correctly as well, and that we have this one there. So let's just put some other color there and maybe rotate it by radians, or no, let's stay with the degrees. I like those more. So let's see. So now I will have a different color here. Color 1, 2, 3. And I could, of course, now create some sort of macro to create this test, those two, or this parameterized tests kind of for me. That is, if I read about it, I've read about it, and if I understood it correctly, that would be the preferred Rust way of something like a data provider, which I would use for something like this in another language. But yeah, I guess I'm not doing this here now for this easy thing here, because actually I don't see why, and it makes things harder to read in this case. So let's see that everything still is working. Okay, so this is working as well. So let's gap source WorldLoader YAML. Let's see what we have changed there. Let's make this a little bit bigger. Yeah, we changed quite a lot. We added those two tests, I guess, and this is all right. So test YAML WorldLoader properly parses stripe patterns. We are for now checking if striped patterns are transferred correctly into their material. Once there is more than one pattern, which is currently only the stripe one, we need to test those specific ones as well. I guess we will not be able to write a general test for this, for all patterns, because all of the patterns will have different properties here. We might have another pattern which doesn't have a color A or B, or which might have 4 colors or only one, or I don't know, or something completely different which we need to be able to configure there. So yeah, we'll see. But this for now is working out quite nice. I like that. So where we didn't write something else was, let me see, I guess I marked it with a to-do. Add tests validating the pattern. Oh yeah, we can actually now remove this. So we have this to-do here, and now this can go away. Let's quickly yes, let's quickly add this to our last commit. Okay, so now that we have done this, let's see what other to-dos and fix-me's do we have, because I'm quite sure I marked some tests to be implemented. Check if we can ensure more explicitly the 2 operands implement the fuzzy. No. Implement proper lighting. Yes, we will maybe do that in the future. Refactor to utilize one matrix struct in the future. Okay. Are there any fix-me's? Because I'm quite sure I've marked missing tests somewhere. Maybe not needed anymore. Could be removed and placed. Yes, maybe. Find a nicer way to do this. So I'm not sure what this was, but it wasn't regarding tests, I guess. Oh yes, it was the submatrix implementation, which I never quite liked. Okay, so but there were tests missing, and I'm quite sure there were tests missing regarding the stripe pattern, because the last time we implemented transformation on stripe patterns, and we never checked that this transformation is correctly applied. And so I guess we should actually do this. So I guess we should create some tests that ensure that there are that the transformations that we applied now here, we are actually applying two transformations, or better said, the inverse of those transformations. So we are first moving moving the coordinate space into the object space, so that it is relative to where the object is positioned in the world and not relative to the world itself. And then we are transforming it again by a transformation which may apply to specific patterns. So the one that we have, let's see, the one that we defined here would be the pattern specific transformation. So we are scaling the pattern and we are rotating it then so that it applies to this object here, but it is correspondingly transformed to this transformation. But first we need to transform the whole thing into the object space here, so where this sphere is actually transformed into, because if I'm removing this, you can quickly see that it is always this default here. And if we wouldn't have done this, it would be something different, because it would just be relative to the world and not to the object. So it might have been moved because we have moved this object here, but the pattern doesn't know about this. So this is actually what we implemented the last time. So, but we didn't test it. So I would like to create tests for this now. So let's do this and let's create tests for that. Yes, so let's create a test here. Maybe striped pattern with or adheres to object transform. And yeah, what would we need first? I guess we would need a transform, of course. So let's create one. Maybe a scaling transform. Those are always quite nice because we can easily reason about them and think about them. So then we would need a body, I guess. So let's create one from, let's create just a default sphere. Come on. A default sphere, but with, of course, the transform that we defined. No. There it is. So there is a semicolon missing. Go into the right line there. Okay. Yeah, and then I guess we need our pattern which we want to be applied there. So we could just pattern from striped default, and I guess the stripe default would be, yeah, maybe we would change this in the future. So yeah, maybe let's with specify the colors here. So let's do a color, and this time we can use the shortcuts we have there. So let's do this with a color black and a color white. Now we should have the pattern, and then we of course need a material to wrap this pattern. Material, which would be a material from Fong default with pattern. Oh. And the pattern in there, and let's see. So now we actually, oh, I guess I need to I need to create this sphere last, because I need to specify the material here. I could have added it later on, but I guess this one makes things a little bit clearer. So now we have that body. I guess I don't really need this material, do I? because I really only use this body to extract its transformation matrix here. So I guess I could do something like assert fuzzy equality between, okay, let's see. We should now have, if we have this transformation here, let's see, we are scaling by 2. So so if we wouldn't be in the object space, then at position 1.5 the color would already be white, because we would stripe it by intervals of 1. But as we are scaling this by 2, the color at 1.5 in our scaled object system should be still black. So let's see. So we are expecting color black. There is a missing. So, and now if we just ask this one for color at, and we are giving it a position, which of course is a tuple, and it's a tuple which is it a point actually? Should be a point. It's a position. It's a specific position. Yes. So it's a point, and on X we are saying 1.5. The Y and the Z are of no real consequence to us. And we are providing it with the reference to this body so that it can actually extract the transformation matrix there. Then we would see syntax error, expected an item. What did I do wrong there? I've not... Oh, yeah, now I see it as well. So let's see, cargo test. Okay, so this works. So this is quite nice actually, because I will quickly show you what would have happened if this transformation wouldn't have been applied. So if we don't have a scaling here, which would be the case if it wouldn't have been applied, then this test would of course fail, because there would already be the color white there. So this is working out as we expect it to. So this is nice. So we now have our basic test that it applies the object transform. So I guess now we need a test to check if it adheres to the pattern transform as well. So yes, so I guess in this case we will simply create a body which has a default transform, and we will, wait a second, tell the pattern that it now has a transform, and this one is the transform here. So let's format this, and as it is the same transformation now, it should actually have the same result. Let's quickly check. Yes, that's working. Okay, nice. And now, yeah, I guess let's add a third test which checks that stripe pattern adheres to object and pattern transform, I guess. So maybe both of those are scaled up by 2. So why not? So let's see. So we have this transform here, and we have our body, and it has a with transform as well. And now, as we are actually scaling it up by 4, even the 3.5 position should be black. And maybe we should add another test here which ensures that at the position of 4.0, and I guess it should be at the border already, because we are 0 indexed and therefore we are starting on the border, so should be white then. So yeah, let's see if this works out. And it works as well. So nice. So yeah, we now have checked that our Pattern transformation is working as it should. Where's my terminal gone? There it is. So let's see. Let's add this one. So we changed things in the pattern, I guess, and the other ones are still from our debugging session. Yeah. So yeah, this is only our tests. So test that striped pattern is transformed according to, or is transformed with regards to object. The patterns that the stripe pattern adheres to object and pattern space. The tests are making sure that the corresponding transformations are applied to ensure the pattern is processed within object space of the body it belongs to, as well as its own transformation matrix. Yeah, so we have those tests in there. Yeah, so I guess we actually did what I wanted to do this session, even though it took me longer than I wanted it to actually take me because of the bug we had there in fuzzy equality. But nevertheless, I'm quite happy with how this turned out. So I had some minutes to play around with the debugging part here and check that I can actually define breakpoints and so on, which is quite nice. Maybe we could take a look at something else when we are here, which was mentioned actually by someone on YouTube in a comment. Let me quickly get this out here so that we can take a look at it, because I think there was a comment which told me that there might be a bug somewhere, and yeah, we could take a look at this if we are in the process of fixing bugs and writing tests. So yeah, Biff and Hap told me that, first of all, thank you for the nice comment that you are really enjoying this series. I am too, so yeah, thanks. That he thinks that the for loops in create canvas tests are wrong. It is a comment to the 5th episode of the Raytracer challenge, so maybe we have changed this. But yeah, he says that ranges in Rust are half open, and I guess I've answered him already, because I'm remembering that I might have actually addressed this issue already, that I found out later on, and that I addressed this and fixed this. But let's see, I think your loops in the create canvas tests are wrong. So let's take a look at the loops in the create canvas test. So canvas. Is there a create something? What did I just creating? There, a test creating a canvas. So there actually is a loop, and it's going from 0 to C width, which would be okay because we are 0 indexed, and so we are actually looping through all the pixels there. So I guess I might have changed this. So let's see, 3 months ago. Yeah, fixed iteration bounce off by 1 error. So actually, yeah, as you can see here, I realized this later on, or maybe someone else already realized this, and I fixed this. Actually, I've even referenced an issue here, so it seems to me, yeah. So yeah, there was another nice chap. Oh, I already forgot about that. Mod Phoenix, which commented on the GitHub of the project here, and told me that this actually is an error. So yeah, I fixed this because now it has been brought to my attention by 2 people. So thank you very much, and please get the comments going. Please open issues for this if you think something is wrong, or you want me to correct something, or comment in YouTube, or use Twitter for this and contact me directly there, or any other means you have to contact me. Please keep the input coming, because I'm always glad to take a look at stuff like this and then fix it up to make things better. So yeah, I guess even though this was quite a not very, I wouldn't say not very productive session, because we actually did what we wanted to do here, even though it took us quite some time. But I guess we are at the end of this session here. So let me check if I push the results here. Push. Yeah, and everything seems to be okay. Clippy is confident about this as well. So let's see, do we have something else in here than what we changed to? No. So let's just reset these changes here. And now, yeah, we have our foo and bar files. We can remove them. So let's be a good citizen here and clean up. And yeah, so thank you very much again for following along here this this session about where we now actually added tests to this. Very much appreciated here. I will quickly do one thing, because I like this as the default view. Now that we have the capability to actually put this striping here in the default of our Raytracer REPL, I guess I would like to have it in there as a default when it's opened up. So let me quickly change this default. And yeah, we of course need another shell for this. So, because we need to be in the Raytracer REPL, so let's quickly open this one up here. And let's see, I guess yes, I know. So there is, I'm not 100% sure, but I think I have, yes, I have this one in here. So let me just, yeah, I know. Let me just paste in my changes here with the, where is it? There with the pattern, the stripe pattern, which is rotated, because I like this. And this would be then the default. Maybe we could even change the second camera to be a little bit of a higher resolution by default. No, it's fine. You can do this on yourself, so for yourself if you want to. So no, I didn't want to do this. So now let's see, I've got a change there. Let's get this up there. Let's first run start dev, just to see that it is working as expected. Okay, so is it just dev? It is just dev. So it now does a live build of what we are doing here, and let's see. Now there should be, where is our browser? There is our browser, and no. Oh, I closed the thing already again. So now this one should, yeah. This works and shows our striped sphere by default, which I quite like. So let's get back to our shell here. Let's clear this one and let's do a run build. Or maybe we could, as we have just updated the code base again, even though we didn't change functionality, we changed tests. Let's base this on the cargo update, on the new repository here, and let's then do npm run build. So perfect. And now we can do, let's quickly check that this worked out as it, there is something, yeah, there's just, oh, it's not in screen. So yeah, so this works. First there was the cache. Not 100% cleared there. So yeah, now we can do an npm run release website. Oh, I didn't commit this, did I? No, I wanted to, damn. Git add source. No. Sort. Wait a second. Git git source worlds. Wait a second, something is severely broken here. So yes, the public git add source worlds 3 spheres.yaml. Yes. Oh, it was already, I just didn't commit it. So no, yeah, change is not staged for commit. Okay, good. Change default rendering to use striped pattern for center sphere. In order to present the pattern capabilities as well as showing the syntax to define it, we are now presenting the center sphere in a striped design by default, and I very much like that. So let me push this. And now let me do come on, npm run release website. Let me do this again. Yeah, because the system doesn't allow me to publish something that I haven't committed, which is quite a good thing. I still find it not amusing, but a little bit interesting that the Rust build process of our Raytracer is actually faster than the building of the JavaScript bundle we are using here. I understand why this is the case, because within the JavaScript bundling process I'm doing quite a lot of optimization stuff and so on, and there is part of the WebAssembly optimization in there as well, but yeah, it's always a little bit irritating me. So now we actually should, if I open up the browser again and I'm, where is it, refreshing our Raytracer XYZ, more than... Why is the cache not properly cleared there? Okay, I guess I need to... there, now it worked. But I guess I need to investigate this, because it should clear the cache if there is a new version. So if you have a problem with not a specific feature not correctly working in this thing, please load or clear your cache and try again, because there seems to be a bug at the moment. I will need to take a look at if there are certain cache headers not correctly sent maybe, and therefore the system doesn't understand that it should throw away some information and get the new version of it. Yeah, so I'm quite happy nevertheless with what happened to this and what we achieved today by adding the tests here with regards to, no, this is the wrong editor, with regards to the WorldLoader, which now has tests for the pattern, and the pattern itself, which now has tests for the camera transformation. And I like that we now caught up with that and are in a state where we can finally go ahead and implement more patterns. So the next session will be the implementation of another pattern. Let me check what is the book going to do next. We are going to do a gradient pattern, and we are going to do a circular pattern and a 3D checker pattern. So yeah, that actually sounds quite nice. I'm not 100% sure that we will do this in this order, but we will see. So those are the next patterns the book suggests here. So I guess we will be doing those. And then we will see. I would love to implement some kind of noise patterns so that we can actually distort patterns using noise, which is quite common actually to be done in 3D rendering, to achieve a little bit more of a lively effect, to make things more organic, because in the nature you don't have perfect patterns. So let me see, does the book do something like this somewhere, or should we do something like this, or is it there is an appendix in the book where are further things suggested that could be done once you have completely finished the book. Let me see, maybe there's something in there. So there we actually have perturbation of normals, which isn't the same thing but goes into the same direction, I guess. Have we somewhere perturbated patterns? Oh yes, they are even suggested at the end of the patterns chapter directly. There is not specifically told us how this is going to be implemented or stuff like that, but at least it is said that something like this exists and that we could do this if we wanted, and I want to. So I guess we will implement this then. We may need to implement Perlin noise or something like this for that. Even though I'm quite sure there will be Rust libraries to actually give us a Perlin noise, but calculating Perlin noise is not that complicated. And as I've done until now, I would like to have the rendering logic, at least like the calculations we are doing there, within our Raytracer and done by myself, just to further learn Rust and to have this as a kind of a isolated project here. So yeah, we will most likely implement this then for ourselves. But yeah, this is something we will do in the future, not now. So the next session, further patterns there, gradient patterns, radiant patterns, 3D checkerboard patterns and stuff like that. Maybe we should do a 2D checkerboard pattern first. We will see. Yeah, so thank you for joining me again and checking out how we are writing these tests, how the minimal kind of debugging of this does look, and fixing bugs there, which we found, which is always a nice thing and always proves me right that it is a good thing to write tests, even though we didn't really find a bug in the code that we explicitly tested, but if we found a bug in the code that is used for the testing comparison here, which is good as well. So tests are nice and a lifesaver. And the best thing about tests, in my opinion, is you can make a change, you can run them, and you are sure that your code is still functioning as it should have, as it should be. You can refactor something, run the tests, and see, okay, everything is still all right and doing its job. And that gives you a peace of mind that I really love. So thanks for joining me again. If you like this session and want to be informed about the next one, please hit the subscribe button and the little bell. And if you like this video, please give it a thumbs up on YouTube, because this really helps. And as always, if you have any questions, please leave me a comment or contact me on any other channel or way, and I will do my best to answer them. So yeah, see you in the next one, and bye!